we're going to give you the level of significance alpha, and here's how you compare the p-value. If the p-value is less than or equal to alpha, then you reject the null hypothesis. If the p-value is more than alpha, then you fail to reject the null hypothesis. Fail to reject the null hypothesis, guys, doesn't mean that you accept. So don't change this language to accept. And I'm going to give you an example why you should not say accept. You just fail to reject the null hypothesis. And fail to reject, again, does not mean acceptance. And let me just give you an example of why. That's a good example that will explain that to you. Okay, let's say someone claims that there is no water on Mars, the planet. And then the alternative hypothesis, guys, will be there is water. Okay. Let's say they send, you know, just those robots there, and they check and they search an area 20 square miles area, and they don't find any water. Okay, can you conclude that there is no water on Mars if you just do an area of 20 square miles? So you could not find water. So you could not, you know, just there is water in 20 square mile area. The Discovery, the robot, you know, that they sent to Mars could not find any water. Is this enough evidence to conclude that there is no water on Mars?
No.
Why not?
Because you haven't looked at the total.
Exactly. So when you fail to reject the null hypothesis, based on the evidence you have, you fail to reject it, but it doesn't mean that it is true. When the jury, guys, say there is not enough evidence to convict the defendant, it does not mean that the defendant is innocent. It just means that they don't have enough evidence beyond reasonable doubt, you know, just to convict the person. But that does not mean that the person is 100% innocent. And the same thing, if you use, you know, just some area on Mars and you don't find water, it doesn't mean that there is no water because you didn't search in all areas. But for what you have, you can make a conclusion that I don't have any evidence to say that there is water now, but it doesn't mean that there is no water on the entire planet. So when you say the word, guys, fail to reject the null hypothesis, don't change it to accept the null hypothesis. Just leave it, reject or fail to reject. So this is a language that you need to learn. Okay, I'm gonna go, I'll come back, you know, just to those after I start one problem right here and show you how to perform hypothesis testing. Okay, we'll come back to this. These are the steps of hypothesis testing, guys. We're gonna state the null and the alternative hypothesis, identify the claim. You already know how to do that. And then I'm gonna show you guys how to do step number 2, step number 3, step number 4. We already stated step number 4 here, guys. If the p-value is less than alpha, we reject the null hypothesis. If the p-value is more than alpha, we fail to reject the null hypothesis. You choose one of the two. That's step number 4, where it says, make a decision to either reject the null hypothesis or fail to reject the null hypothesis. And then number 5, guys, interpret your decision in words in the context of the claim. Say it in words so someone can understand, you know, just what this claim was about and what is the conclusion of the claim. Before I do this, guys, I want to do some algebra and show you how to compute some algebraic expressions like this using the calculator. So let's do that together. If you have, for people who want to do the work by hand, I think it will be useful to follow with me on this. Most likely we'll be using the calculator throughout, but let me show you how to compute those numbers and put them in the calculator. Okay, so how would you input this into your calculator, guys? You can do open parentheses. Because the numerator has two terms, we have to put in between parentheses, 110 minus 105. So this is the algebra that you need for this chapter, divided by, and for this one, guys, put in between parentheses as well. So I have 12 divided by second and square root of 35. Watch, guys. And then to get out of this, guys, just press here. You're out and put parentheses. So this is how you enter the same. Don't forget the parentheses on top. Otherwise, you're going to get a totally wrong answer. So look, and that's the answer. That's Z. Usually we round Z to 2 decimal places. So that will be 2.47. Okay, T. Let's do this together. Same thing, guys. Enter 10.1 minus 11.4 divided by, and open parentheses, 5 divided by square root of 12. So you press the second key, x squared 12, get out and close. You can write it down in your notes that this is what we're doing exactly. That's going to be a negative answer. Usually T to 3 decimal places. So if you do 3 decimal places, it will be negative 0.901. And last one. Again, guys, you might not need to do this computations by hand, but when you do help me solve this, etc., he's going to show you how to do the work by hand, but you will be able to use the calculator programs to get those numbers, which I know they're not making any sense to you now, but they will later. 0.55 minus 0.52. Don't forget parentheses. It's critical that you put parentheses. If you don't put parentheses, what the calculator will do will take 0.52 and divide it by the denominator only. And we need a square root. And you can simply just put in there 0.55 times 0.45 divided by 200. And you want to exit, you just press here. And here you go, 0.85.
I'm sorry, for the third one,
Mm-hmm.
when you put in there the square root and you did, is that a 0.55 minus 0.
No, times.
Oh, that's a
That's
multiplier. Okay.
multiplication, yeah. I know it looks like minus, but it's multiplication. All right.
Professor, I just had a really quick question. I don't know if it's like a dumb question, but like, so how do you know, like you're doing 2 decimal places or doing 3? Because sometimes.
Oh, that's a good question. When we do a Z in I'll tell you, when the problem is about Z, it's going to be 2, and it is about T, it's always a 3, which will distinguish that in the sections. Remember, in chapter 6, we did Z interval and T interval. It's going to be the same thing in chapter 7. So anything that has to do with Z, it's always involved 2 decimal places. Anything that involves with this value T will involve 3 decimal places. No, it's not a dumb question. That's a good question. All right. This is alpha, guys. and the p-value is less than alpha. So what do we do? Did you memorize what we say? Do we reject the null hypothesis or fail to reject the null hypothesis?
Reject it.
Reject. Guys, the whole story in this chapter is how to find the p-value and make a decision to reject the null hypothesis or fail to reject the null hypothesis. Okay, now alpha is 0.01. We know 0.0237, which is the p-value, is bigger than alpha. So what would be the decision?
Fail to reject.
Fail to reject the null hypothesis. And don't put the word accept, guys. Fail to reject the null hypothesis. Alpha will be given to you in the question, guys, but he won't give you two values of alpha. There will be only one value, but I'm just showing you if alpha is 5%, the p-value is less than 5%, we end up rejecting. See how important alpha is. Now, if we make alpha smaller, 0.01, we end up failing to reject the null hypothesis. That's why it's very important in a statistical study to know what alpha is and what value it has in order to compare it with the p value. All right. Okay. We're gonna start an exercise. Okay. So the steps of hypothesis testing, guys. The first step is to state the null and the alternative hypotheses, as you can see here. The second step is called calculate the standardized test statistic, which I'm gonna do it, show you what this value is. And this step 2 is gonna lead to the p-value, which is gonna show us how to find the p-value. I'm gonna do the work by hand first of all, and then I'm gonna show you how to use the calculator right after. And then step 4, guys, once you find the p-value, compare it with alpha. If the p-value is less than alpha, you reject the null hypothesis. If the p-value is more than alpha, you fail to reject the null hypothesis. And the last step, guys, write your conclusion in words in terms of the claim. All right. And let's do one exercise. I'm going to walk you through this question step by step. And there's a worked out example. Okay, let's do this exercise, guys. A worked out example. The Center for Disease Control, CDC. I'm sure you heard about CDC. You've been hearing about it for over a year because of the virus. Reported on trends in weight, height, and body mass index from the 1960s through 2002. The general trend was that Americans were much heavier and slightly taller in 2002 as compared to 1960. Both men and women gained approximately 24 pounds on average between 1960 and 2002. In 2002, the mean weight for men was reported at 191 pounds. Suppose that an investigator hypothesizes that weights are even higher in 2006. That means the weight is even more than 191. So someone is making a claim, guys. We know 2002, the mean weight for men was 191 pounds. And now somebody, an investigator, is making a claim that they are higher in 2006. So would you guys agree with me that the claim here, mean is greater than 191 pounds? Do you agree with this statement? Yes? And the null hypothesis will be what? Less than or equal to 191 pounds. And this is where the claim is. Well, if somebody makes a claim, guys, they better provide us with data. They have to collect data and see to support their claim. So let's see what this investigator did. In order to test the hypothesis, we select a random sample of Americans male in 2006 and measure their weights. Suppose we have resources available to recruit 100 men into our sample. So the sample size, guys, is 100. We weigh each participant and compute summary statistics on the sample data. Suppose the sample determined the following. X bar is 100. So we measured the weight of 100 men. Their sample mean weight was 197.1 pounds, and the population standard deviation was 25.6 pounds. Can we support the investigator claim? So this is an example, guys, of a hypothesis test, which I'm going to walk you through the steps and how to perform, such a test. So I'm going to just get a blank sheet of paper and do the 5 steps together and show you how we perform the test and perform the 5 steps. Okay. 1 second. So please pay attention to this. Well, I'm going to do it by hand first, and then I'll show you how to use the calculator to perform test. All right, guys. So this is the first step. It's called the step number 1. State the null and the alternative hypothesis. Okay, let me show you what step number 2 is. This is new. You haven't done that yet. Remember, we have a formula for z-score, which is x minus mean divided by sigma. That was what you learned, guys, in chapter 2. And then you learn, guys, in chapter 5, when we work with sample mean with x bar, and this is what we're working with here, the sigma changes to sigma over square root of n. And this is called the test statistic. I'm going to do it by hand now, but actually later, guys, you don't need to do it by hand. You will be able to use a calculator to compute this. And probably this should give you a clue of why I did those algebra questions and how to compute those values using the calculator. So the second step is to find what we called the test statistics. So converting this value x bar to z-score. And this is the formula that we use to convert the value. And let me show you how to convert this value right here. X bar, guys, is 197.1. So you put 197.1 minus. Okay, remember, in any hypothesis test, we assume that the null hypothesis is true until proven otherwise. And we're going to assume that the null hypothesis is true until proven otherwise. So we need the mean here. If we assume that the mean is less than or equal 191, we can use the equal sign here for 191 and put 191 right there. So you always, this one here, guys, you get it from this number right here. Put it here. Over sigma, which is 25.6, divided by square root of n, square root of 100. Would you guys help me out, please, and compute this number for me?
196.35.
The final answer?
Yes.
Can't be. That's too big.
I got 2.38.
2.38. Let's see. Let's do it together. So we put open parentheses 197.1 minus 191, close parentheses, divide. Open parentheses, probably forgot to open parentheses here, 25.6 divided by, well, I know what square root of 100, guys, is 10, so I'm just going to put 10 here. And let's see. 2.38. I agree with this. All right. So step number 2, we will give you this value, guys, this formula. You don't need to memorize it. So X bar, you just take this value and put it here. Minus the mean, you pick it up from the null hypothesis always. Sigma will be given to you, and n, and you got this value. Let me tell you what the p-value is now. Step 3, calculate the p-value. You're gonna love the calculator soon because you don't need to do any of this work, but I'm just gonna show you what the p-value is. Okay. Answer this question, guys. Is this a right tail test, a left tail test, or a two-tail test?
Right.
Oh, this is a right tail test.
Excellent, right tail test. So let me tell you what the p-value is in statistical terms. You saw the p-value in the context, just of those examples in the videos, but let me tell you what the p-value is. So you agree this is a right tail test. Okay. What was the value in step number 2? What was it, guys? 2.38. That's the Z line. This is the normal curve. We assume that the population is normally distributed. Would you guys agree with me if I put 2.38 to the right of 0, it should be somewhere here? Yes? Because it is a bigger number than 0. Let me tell you what the p-value is. Because this is a right tail test, the p-value is the area to the right of 2.38. If this was a left tail test, guys, the p-value will be the area to the left of what you get in step number 2. And if this was a two-tail test, the p-value will be the area to the right and to the left of what you get in step number 2. So 2.38. Does anyone still remember how to find the area to the right of 2.38? This is chapter 5, guys. Anyone remember how to do it?
Wouldn't you minus 1?
No, we're not gonna. Yeah, if you use the table, we're not gonna use the table. We're gonna use technology. So this is a probability, guys. Do you still remember the normal CDF? Okay, normal CDF. What's the lower bound here? 2.38. Upper bound 1,000,000 and 0 and 1. But no worry, guys. This is just temporary. We're doing it this way. It's gonna all come by itself later. So you will get second and distribute, normal CDF, 2.38, 1,000,000, 0, 1, paste. And I got 0.00. Okay, p-value 4 decimal places, guys. So can someone tell me what would that be to 4 decimal places?
0.0087.
Exactly. Excellent. You've done with step number 3, guys. That's step number 3. Step number 4 and 5 are no-brainer. You're gonna see once you get step number 3, you're almost done. Step 4. Do I reject the null hypothesis or fail to reject the null hypothesis? Remember, alpha is 0.01. It's given to you. Well, do you guys agree with me that this p-value is less than alpha? Do you guys agree that 0.0087 is less than 0.01? You have
Yes.
to determine. So then reject the null hypothesis. All right. And now the last step. Step 5. Let me show you how to state step 5. This is for the reader. This is someone who doesn't understand statistics. We have to write the steps and to tell them whether we support the claim or not. Okay. You reject HO. And your claim is in HA. Will you support your claim, guys? Yes or no? Our claim is in the alternative and HO turned out to be not good, bad. So would you guys agree with me that HA is good? That means,
Yes.
the claim is good. And here's how you state the language. Look what you say. You're not gonna decide how to state this language. You're gonna memorize this language, guys. You say, there is enough evidence. Just like in the trial court. What's the level of significance here? You have to mention to a reader that there is a chance that you made a type 1 error. So you're not going to tell the reader that you're 100% sure. There is enough evidence at the 1%, at the 0.01 level of significance.
Professor, where did you get 0.01 from?
Oh, this is the alpha. This is the level of significance given to you in the exercise. This is the maximum allowable probability of making a type 1 error. And this value, this is the value that you compare the p-value with always. You need this value to compare the p-value with. If he doesn't give you anything, guys, in the problem, use 0.05. But most of the time, we will give you the alpha. So there is enough evidence at the 0.01 level of significance to support the investigator claim, and just copy it and paste it from the problem. What was the claim of the investigator, guys? Let's read it. An investigator that the weights are even higher in 2006. That the weights are higher in 2006. So we were able, guys, to support the claim of the investigator. That means, yes, American male in 2006 have more weight on average than what they had in 2002, I think, or 2001. And this is an example of how you can perform a hypothesis test, guys. Let me show you now the good part of it and how you can use your calculator to perform this test. The calculator, guys, is going to do step 2 and step 3 for you. So you don't have to do the calculations by hand. But the calculator will require from you that you provide n, you provide x bar, you provide sigma, and that's it. So let me show you how to use the calculator. Ready for that? So turn the calculator on. Whatever we went to do chapter 6, it's going to be in the same place. So you press on stat and you go to tests. Guys, we're not doing intervals anymore. We're performing tests. So you're going to look for the words that have tests. Now, if sigma is given, please write a note here. If he gives you sigma, the population standard deviation that's linked to a normal distribution Z, it's going to be Z-test. That's a Z-test. So I'm going to press a Z-test here and watch, guys. Okay. Please answer those questions for me. Let me tell you what each one means. First of all, the input. Do you have a summary or data? Well, he gives me a summary. He didn't give me the actual data, so it's always a stats. Mu0, he's telling you what was the value that you put in the null hypothesis to begin with. Can you guys tell me what this value is? Let me see.
191.
Yep, 191. That is correct. Next, he wants sigma. What's sigma, guys? Read it off the screen.
25.6.
That is correct. Next, he wants X bar. Yeah, 25.6. I agree.
197.1.
No, 197.1. I'm going to go slow with this, guys, because once you know how to do it once, you're going to be able to do it all the time. And what is N, guys? The sample size. Yes. Let me see. 100, yes. Good. I'm following the chat as well. Okay. Can someone guess what does he want, what the program wants before we hit calculate?
They want the claim.
No.
They want the alpha.
They want the alternate.
Alternate hypothesis, exactly. We don't care where the claim is. The program wants the sign from the alternative hypothesis. And the sign from the alternative hypothesis, as you can see, guys, is bigger than you have to choose it. We don't care where the claim is, just choose the sign from the alternative and press enter. You better make sure that it is grayed in, guys, otherwise it won't be selected. And now hit calculate and watch. You're gonna like this. Oh, we got Z and we got the p-value. That's step number 2, guys, done for you. And that's step number 3. It's already done for you. You see all the work I did? That's step number 3. All you need, you still have to do step number 4 by hand. Take this p-value that you got off the calculator and compare it with alpha. If the p-value is less than alpha, you reject the null hypothesis. If the p-value is more than alpha, you fail to reject the null hypothesis. We reject HO. If we reject the null hypothesis, guys, and the claim is in HA, we support the claim. We say there is enough evidence to support the claim. All right. So, and let me show you another way you could have displayed this. I'm going to go to Z-test one more time. Watch. All right. Instead of calculate, I'm going to hit the draw. It will draw the p-value for you, but it's not going to show you nothing because the p-value is so small. There you go, guys. You see what's shaded in blue here? This is the p-value. Look, this is the test statistic 2.38, and this is the p-value 0.0086. That's how we use the program to find the p-value. Okay, let me...
Are the steps the same for the older calculator?
Yes, it should work. All right, let's do another one together. I'm trying to make it easier and just put the steps, guys. So I will always guide you in most of the problems, you know, just with the steps for now. So let's do this one together and please participate with me. Have your calculator handy and let's try to do this one. The EPA reports that the exhaust emissions for a certain car model has a normal distribution with the mean of 1.45 grams of nitrous oxide per mile and a population standard deviation of 0.4. So sigma, guys, is 0.4. The car manufacturer claims that their new process reduces the mean level of exhaust emitted for this car model. So that means they go below the average. We know the average nationwide, the EPA reports as 1.45. But a new car manufacturer claims that their new process reduces the mean level of exhaust emitted for this car model. Can you guys help me state the null and the alternative hypothesis here? The EPA say the normal range is a mean of 1.45, but the car manufacturer is saying that their car have a mean level of exhaust emitted for this car model that is lower than what the EPA claims. So how would you state the null and the alternative? Who would like to participate? This is the acceptable level. But this car manufacturer said there's even lower. So let me see.
So would the H or the null be the mean is lower
No, lower should go, lower
or
should
equal
go
to
where?
then the 1.45?
Yeah, that's it's against 1.45, guys.
Okay, so I'm sorry, it's alternative is
The alternative, it's lower.
lower.
Yeah. And that's the null. And your claim is in the alternative. A simple random sample of 31 cars, N is 31, guys, has a mean level of exhaust emitted for this sample is 1.21. X bar is 1.21. State the null and the alternative hypothesis. Calculate the test statistic. Guys, we're going to do this on the calculator right away. Watch. So we're going to go here. I'm going to turn the calculator on. I'm going to hit stat, tests. It's a z-test. Again, if you ask me why a z-test, because it says population standard deviation. Once it says population standard deviation, you must use the z-test. Okay, enter. Mu0, what goes in here, guys? Just help me out.
1.45.
Exactly. Sigma is 0.4. X bar, guys, he gave it to you right here, 1.21. And remember, N is 31. Okay. First, second, or third, guys. This is the sign in the alternative hypothesis. I don't care where the claim is. It happened to be in the alternative, that's fine. But that's the sign in the alternative hypothesis. So I choose the first, middle, or last.
Middle.
Okay, second, yeah, I agree with you guys. Enter. And I'm gonna hit the draw, guys. I wanna show you the p-value, a visual of the p-value. Watch.
So when we change the sign, that means that's the HA.
Yeah,
Okay.
that's HA, exactly. So this one here, it's the HA. You're choosing HA, exactly. So make the correct choice, because if you don't make the correct choice, your answer is gonna be totally wrong. Watch. This is less, oh, you didn't see any shading, that means the p-value is very small. So Z is 2 decimal places. What would that be, guys, for 2 decimal places?
3.34.
Yep. And p-value, let me tell you what the calculator showed me, and then we'll interpret that. So that's good, we put that. Okay. Don't write it like this, guys, and don't write it like a 4. It's not a 4. E minus 4 means you have to move the decimal point 4 digits to the left. So the decimal point is right here, guys. So actually, if you move it 4 digits to the left, it will be like that. 0.0004. That's the p-value. If you see an E right away, you can say it's almost 0. It's very low. P-value low, HO must go. If you try to remember this, that means if the p-value is low, you have to reject the null hypothesis. What's the decision at the 0.01 significance level? Remember, if p-value is less than alpha, I'm going to write it down, reject HO. And if p-value is more than alpha, fail to reject HO. Do you guys agree with me that this p-value here is less than alpha? Is that a correct statement that I put? 0.004, guys, is less than 0.01. So what's the decision? Reject HO. What do you conclude? You say, when you reject HO, this is how you start, guys. There is enough evidence at which level of significance? 0.01 level of significance. To what, guys? Can someone tell me what's the next word? Are we going to support the claim?
To reject.
Oh, there's students saying they got 8 E minus 4, then that means your alternative sign was not correct. You should have selected less than, probably selected not equal. So there is enough evidence at the 0.0 level of significance to what? The claim is in HA. We reject HO, guys. And the claim is in HA. Do you agree that we should support the claim? This is bad. Then the next one must be good. If the first one is false, the second one is true. Remember, HA is true when HO is false. We're saying HO is false because we rejected it. Once you reject something, guys, you're rejecting it because it's not good. That means the alternative must be good. So you say there is enough evidence at the 0.01 level of significance to support the car manufacturer claim that the mean exhaust is less than 1.45. We are supporting their claim. All right, let me see. Okay, I have enough time to do one more exercise, so we're gonna do one more. But any questions about setting this up, guys? That's very, very important. We're gonna do a lot of work on learning how to state, the last statement. Actually, the first four should be easy because the p-value decides whether you reject HO or fail to reject HO. And then we're gonna learn how to write those statements. Always, guys, when you reject the null hypothesis and the claim is in the alternative, you say there is enough evidence to support the claim. If you don't reject the null hypothesis, guys, you just add there is not enough evidence at the 0.0 level of significance to support the claim. So you don't change much in the language except of just putting not enough evidence. So anytime you end up failing to reject the null hypothesis, here you start with there is not enough evidence. Let's see that in the next question. In an auto racing, a pit crew claims, these are the ones who change the tires and refill, just the car with gas in a few seconds. You see that in car race. It takes them seconds, to change 4 tires. A pit crew claims that its mean pit stop time for 4 new tires and fuel is less than 13 seconds. So this team is claiming that they can change 4 tires and refuel the car in less than 13 seconds. You want to study this claim. You're suspicious. You want to see if this claim is valid or not. So can you guys help me state the null and the alternative hypothesis first? Who will do that for us?
So the sigma would be,
You mean the mean?
sorry, yeah, the mean. Wouldn't it be 0.19?
What's the 0.19?
No, isn't the null meaning that they are less
Oh,
than,
yeah.
I'm sorry, the alternative is less than 13 seconds?
Exactly. Yeah, that's the claim. And the mean, and this one will be greater than 13 seconds. Is this clear to people? Please understand this before I proceed. Let me tell you if any question. Let me know if any questions about this. Yeah. Yeah, sigma is 0.19. That is correct. Students who said that is correct, but we don't need that yet. We need to still make the statement. So usually, guys, the first sentence in a hypothesis test problem is, and we'll give you a clue of how to state the null and the alternative. Usually the first sentence, most of the time. Look, in auto racing, a pit crew claims. Once you start reading the word claims, be ready to write the null and the alternative hypothesis. Mean. So look, I put the sign of mean here. I didn't put P. Is less than 13. Just copy it, translate it, guys. Mean less than 13, and that's it. Now, if this is less than 13, the other one should be greater than. Remember what I did before. If you have this in the HO, you should have this in HA. If you have this one in HO, you should have that in HA. And if you have an equal here, you should have not equal. Guys, these come in together always. All right. A random sample of 32, so you guys agree with me that n is 32, has a sample mean of 12.9 seconds. So X bar is 12.9 seconds. Assume that the population standard deviation is 0.19, which is sigma. Is there enough evidence to support the claim at alpha equals 0.01? He gives us alpha is 0.01. Let's do it, guys. Same thing as we did previous exercise. Z-test, and you ask me why Z-test? Because he gives me sigma, population standard deviation. So enter. Okay. Help me out, guys. What should go here? What number?
13.
13. Sigma. What is sigma? 0.19. X bar 12.9. N is 32. And which sign now?
The middle.
The middle one. Yeah, it happened. Those three exercises be in the middle. I didn't intend for it to be that way, but that's what the exercise is. And hit calculate, guys, if you want. So Z is negative 2.98. The value is, let me show it to you again. It's very small, 0.0015. The reason why I don't put equal, guys, because it's not exactly equal, it's approximately. And you guys agree with me that this is less than alpha, which is 0.01. You will see some problems next week when we do it, you know, where p-value is more than alpha, it's not less than alpha. So, and what's the decision, guys? Reject HO or fail to reject HO?
Reject.
Reject HO. Again, guys, if you reject the null hypothesis and your claim is in the alternative, sorry, it should be HA here, then you support the claim. So look what you write. There is enough evidence at the 0.01 level of significance to support the claim that the mean, I'm just copying and pasting, guys. Stop time is less than 13 seconds.
Can you move your sheet up, please?
Yeah.
Thanks.
Would you guys hire this team if you're in racing business? Would you hire them, you know, just to do the replace the tires and recharge with fuel? Do you think it is safe to hire them? Yes or no? Based on the results, based on our conclusion. They made
Yes.
a claim and we supported them. Yes, I would hire them because we were able to support their claim. So I hope, guys, that you have a feel now how to, when people make claims, when Moderna, you know, just made the claim about, you know, their vaccine and its effectiveness, how the CDC or the FDA approved their claim. They did a study similar to what we're doing, guys. But what we're doing is a very, very low scale. They do it at a lot bigger scale. But this is the idea. They either supported their claim or didn't. I'm sure they did support their claim. That's why it was approved, you know, for emergency use. But this is the idea, guys, of hypothesis testing, to study any claim, regardless of what the claim is, by collecting data and studying the evidence and finding this p-value. Even with Moderna or Pfizer or the Johnson & Johnson, They need it, just to provide the p-values, just and show it to the FDA as well. As I told you, we're doing it at a very low scale, but that's how hypothesis testing is done. So let me stop here and make this.